So now let's talk about the commutative property. As we have learned previously under integers or the whole numbers, if two numbers are free to move around a mathematical operator without impacting the actual result of that operation, then we say that two numbers are commutative under that operation. So adding q to the p is the same thing as adding p to the q, right? Intuitively, it does make sense as well. But let's say, what about the subtraction? Let's say I hold a number 1/3 and I subtract 2/3 from here, right? Is it the same thing as changing the sequence of this subtraction operation? I say that 1/3 is being subtracted from 2/3. Well, no, it is not the same, because when you subtract a bigger number from a smaller number, the result is going to be what? It is going to be a negative, right? But in this case, on the right hand side, you are subtracting a smaller number from a bigger number, right? In this case, the result will be plus 1/3, right? And these two results are not the same. Left hand side is not the same as the right hand side. Hence, we will say that the commutative property for rationals does not hold true under subtraction. Okay. Now, what about the multiplication operation? So let's pick some examples. So commutative under multiplication does hold true. For example, if I take a number p and multiply with q, it does not matter how I put these numbers in different places in this multiplication. The sequence, for example, if I take my first number to be 1/3 and the second number to be 5/7, is it the same thing as stating 5/7 first and then taking 1/3 as the next in the sequence of this multiplication? And yes, it will be equal, because when you multiply two numbers, you don't care in what sequence do they appear. You simply multiply everything and that is your net result. So in this case, on the left hand side, my net result is 5/21. And likewise, on the right hand side too, my result is also 5/21. It is simply a product of the numerators and the denominators. So these two results are indeed the same. So we will say that commutative property for rational numbers does hold true under multiplication, right? What about division then? Well, I will say it does not work on division, because let's say I take these two numbers as an example. If I divide 1/3 with 5/7, it is equivalent to stating that it is multiplication of 1/3 with the inverse of 5/7, right? So it will be 7/5, right? So then the net result will be 7/15, right? But if I were to change the sequence of these two numbers around the division operation, I will say if I take 5/7 first and then divide that with 1/3, what will be my net result? It will be 5/7 multiplied by 3/1. And that will be equal to what? That will be equal to 15/7, right? So you see, there is a big difference. The left hand side is 7/15, which is not equal to the right hand side, which is 15/7, right? So we will say, as a result, when we talk about the commutative property of rational numbers, it does hold true for addition, it does hold true for multiplication, but it is not true under subtraction and not true under the division. So that's what you can conclude about the commutative property for rational numbers.